Okay, I was going to finish up section 2.3 today, I guess where we had left off here was we had just finished up the local min and max for the function given there using graphing utility, and so an exact min or max usually requires calculus, but to approximate the min or max we can use a graphing calculator. The average rate of change of a function on a closed interval AB is f of b minus f of a over b minus a. Okay, now that may look like a new formula, although it's not a new formula. It's exactly the slope of a line. So suppose here's just an ordinary curve, f of x, and here's the point a f of a and b f of b. And I'm going to draw a line passing through a f of a, b f of b. Now we call this line a secant line. Okay, I was commenting on the tangent line. The tangent line is the line that touches the curve at a single point. It's also flowing in the direction as the curve at the point of contact. A secant line is not that. A secant line is going to pass through 2 points, and like what you see here. Okay, and suppose that these 2 points are h units away from each other. So b f of b would be a plus h f of a plus h. Okay, now the slope of the secant line, and this is the secant line, is f of b minus f of a over b minus a. F of b is a plus h, and so I've got f of a plus h minus f of a over a plus h minus a. And that gives me f of a plus h minus f of a over h. Okay, so the difference quotient that we were looking at before is exactly the same as the slope of a secant line. Okay, it's a line that is going to pass through the point a f of a and b f of b. Even though a and b on this curve f of x produce a nonlinear pathway, we can still draw a line from a to b. All right. So, for example, suppose that f of x is equal to 3x squared minus 2x plus 3. Let's find the average rate of change of f from 2 to 1, and then let's also find an equation of the secant line containing negative 2 f of negative 2 and 1 f of 1. Okay. F of b minus f of a over b minus a, and of course a is negative 2, b is 1. Okay, and you always go in order. So f of 1 minus f of negative 2 divided by 1 minus negative 2 is what? Well, f of 1 is 3 minus 2 is 1 plus 3 is 4. Minus f of negative 2, negative 2 squared is 4 times 3 is 12 plus 4 is 16 plus 3 is 19 divided by 3 gives me negative 5. Okay, so the slope of the secant line would be negative 5. Okay, now suppose I want to go take this a step further and I want to find the equation of the secant line. The equation of the secant line. Well, if I know the slope, negative 5, and I know the point that it goes to, -2, 19, and 1, 4. Both those are points on the line. I just use -2, 19. Y minus y1 is 19 equals -5 times x minus x1, x plus 2, is -5x minus 10. Y minus 19 equals -5x minus 10. Add 19 to both sides. Y equals -5x plus 9. Okay. Let's let f of x be equal to 0.5x squared plus 50 represent the outside temperature in degrees Fahrenheit at x p.m. Find the average rate of change of f from x equal 1 to x equal 4. Okay, so the average rate of change is f of b minus f of a over b minus a. I want to find this from a equals 1 to b equals 4. So f of 4 minus f of 1 divided by 3. F of 4 is 50 plus half of 16 is 8, 58, minus f of 1 is 0.5 plus 50, it's 50.5 divided by 3, equals 7.5 divided by 3 equals 2.5 degrees Fahrenheit per hour. So the temperature increased on average by 2.5 degrees Fahrenheit per hour, we would say. Okay, now they're not asking for it, but suppose that this is at xpm. Suppose that this is at xam. Okay, so I'm going to find the average rate of change from 1 a.m. to 4 a.m. This temperature here, I would expect more times than not should be a negative number. Okay? In other words, the temperature usually drops from 1 a.m. to 4 a.m. Okay, usually. So the temperature decreased on average, you know, by whatever it would be, per hour. Okay? Problem 90 on page 94 is a good one. Oops. Let's see here. Here's problem 90. F of x equals 2x squared plus x. Okay, and here's what we've already got. M subsecant equals the difference quotient. F of x plus h minus f of x all over h. H is not equal to 0. In calculus, this is called the difference quotient of f. And this is a very important formula that you do in calculus that you see kind of early on in the summary there in calculus. In calculus, this expression is called the difference quotient of f. So in part A, we're going to express the slope of the secant line of each function in terms of x and h. Be sure to simplify the answer. Okay. Part B, we're going to find m subsecant for h equals 0.5, 0.1, and 0.01 at x equals 1. What value does m subsecant approach as h approaches 0? Okay. So part C, find an equation for the secant line at x equal 1 with h equal 0.01. And part D, we'll use the graphing utility. I'm going to skip part D, but we'll do parts A through C though for problem 90. Okay, so problem 90, I get f of x equals 2x squared plus x. M subsecant is the difference quotient f of x plus h minus f of x all over h? Well, f of x plus h is 2 times x plus h squared plus x plus h, okay, minus f of x means minus 2x squared plus x all over h. I get 2x squared plus 4xh plus 2h squared when I FOIL this out and distribute the 2, plus x plus h minus 2x squared minus x. Okay, so the 2x squareds are gone, x is gone, and that leaves me with 4xh plus 2h squared plus h all over h. And h is in common to those 3 terms up top, so I can factor that out and cancel it with the 1 down under. 4x plus 2h plus 1 is my answer. Okay, and so part B, suppose that x is 1 and h is 0.5. Okay, then the slope of the secant line, 4 plus 1 plus 1 gives me 6. Part B, x equals 1 and h equals 0.1 means that I've got 4 plus 1 is 5 plus 0.2 gives me 5.2. When x is 1 and h is 0.01, I get 4 plus 1 is 5, plus 0.02 is 5.02. Okay, so as h is shrinking, here's 0.5, 0.1, 0.01, x is the same. We can see that it appears that the slope of the secant line approaches 5. Okay, now that's just a guess. We don't know that for sure, but it's reasonable to guess that. Okay, x equals 1 and h approaches 0 means that the slope of the secant line approaches 5. So in part C, find the slope of the secant line, find the equation for the secant line when x is 1 and h is 0.01. Okay, so when x is 1 and h is 0.01, we get the slope of the secant line is 5.02. And when x is 1, let's see here, 2 plus 1 is 3. So 1, 3 is on the graph. And, okay, so I know the slope of the secant line, and I know the point 1, 3 on the graph. I can use the point slope form. Y minus y1 equals the slope times x minus x1. And y minus 3 equals 5.02 times x minus 1. Distribute the 5.02. So you have 5.02x minus 5.02. Add 3 to both sides. Y equals 5.02x plus 2.02. So that would be the slope of the secant line, the one that I was talking about earlier here. Now this would be a secant line, not a tangent line. Okay, you wouldn't find a tangent line unless h is 0. Okay, because the tangent line only intersects at one point and also flows in the same direction as the curve at the point of contact. All right, so there's a little bit of calculus in there. Hopefully doable though. The problems are on page 90. Okay, so I'd like you to look at these problems for homework.